All right, y'all, test two review. All right, y'all, so it looks like the first few are going to be on Math Lab doing graphing stuff. So I'm going to share my Math Lab screen so we can look at the first few problems here. All right, so I'll make this a little bigger here. But they want me to determine visually whether this function is even, odd, or neither. So remember, if it's even, it's symmetric to the y-axis. If it's odd, it's symmetric to the origin. And that's the ones that look the same when I turned them upside down. And then you got neither. Well, y'all, this one is symmetric to the y-axis because that y-axis cuts it right in half. And if I was to fold it over the y-axis, the right side would land on the left side. Also, it's touching the x-axis 2 times, which is an even number. So y'all right there, based on all that data, if your graph looks like mine, it is definitely going to be even. All right, y'all. So before I do this, and let me review y'all a little bit on this transformation stuff. So I'm going to go back to my paper a second. So on number 2, you're dealing with transformations. So I'm just going to draw them all out in one sentence here. So if I got a function that's got I'm just going to put a x plus or minus a, and then plus or minus b. So inside the parentheses, if you're inside parentheses like that, plus goes left, subtraction goes right. So if it's being added, left, subtracted, right. Now at the end, on this one, if it's plus, it's going up. If it's negative, it's going down. So if I add a number at the end, it's up. If I subtract a number at the end, it's down. And then if it's got this negative right here, if you got a negative in front of your function, that negative reflects across the x-axis. If that is negative. So these are the moves we got to look at. Are you inside parentheses, you're going left or right? Are you outside parentheses at the end, you're going up or down? If you got a negative in front, you're going to reflect across the x-axis, okay? All right, y'all, so 2, 3, and 4 are all dealing with this information. So for number 2, I don't have a negative to worry about, so it's not going to reflect it. So it says start with the graph of f of x equals, well, these are those 7 basic graphs we drew. And I see an exponent of 2 there. So since I see that exponent of 2, I know this is going to be the x squared graph. Now, inside the parentheses, we said if it's plus inside the parentheses, that's going to move me left. So that's going to shift me left 5 units. And then we said at the end, if it's negative, that's going to go down. So then it's going to go down 4 units. And then remember, you have to draw the graph. So the x squared graph is this U-shaped x squared tool. You click that and then click on the graph somewhere. It'll start it in the center here. So then you do the horizontal. We went left 5, so move that left to 5. And then the vertical, we went down 4, so move that to negative 4. So it moved my graph left and down. So then I save that and I can go to the next one. Now, on this one, since that x minus 1 is up under the little radical there, you treat that x minus 1 like it was in parentheses. Okay, so since that minus 1 is in parentheses, We said inside parentheses, if it was minus, you're going to move it right. So they're telling you you're starting with the square root of x, and then you're going to shift it right 1 unit. Then you got to pick which graph looks like it went to the right. So I'm just going to sort of make them all a little bit bigger. Whoa, it looks like A is actually starting right in the center. So it don't look like it shifted right. But if you look at number D over here, on D, if I make D bigger, you can tell that it's went right just a little bit, which will be my 1. C looks like it went left, and B looks like it went up. And then A don't look like it moved at all. So that looks like a regular square root of x. So y'all, the one that went right would be D. So we pick D, and then we can go to the next one. So this one we don't have to graph, we just got to tell it what all the moves are. So the -3 inside parentheses is going to move me right 3. The +5 is going to move me up 5. And then that negative in the very front is going to reflect me over the x-axis. So let's see what they're starting with. So we got to go right 3. So we would come down here and click right 3. Then reflect it across the x-axis. That's all you can choose in this section is the x. And then we said we was going to shift it up 5 for that last plus there. And y'all, so that was a trick on that one. All right, y'all, so I'm gonna start writing these down now so I can start working these ones on the pad. They want me to find the zeros of the function. They got f of s equals s squared plus 11s plus 28. All right, so I'm not going to lie. There's many ways we can solve this one. I'm actually going to solve it by factoring. I'm going to solve it by factoring, but you could graph it and look for the x-intercepts. And I'm going to do both of those, okay? You could do the quad formula. I'm not doing that on this one because it's so long. But if you don't know how to factor or use the calculator, you can do the quad formula. So y'all, the first trick was to set it equal to 0. So I'm going to solve it by factoring. So that's going to give me 2 sets of parentheses. So the s squared, that's going to be an s and an s in front of both of your parentheses. This last number is positive. So remember, anytime the last number is positive, both of these factors will have the same sign as the middle number. So both of these will be positive. And then you find factors of 28 that add to get 11. So y'all, 28 is 1 and 28, 2 and 14, 4 and 7. The pair of factors that add to get 11 would be 4 and 7. So now that it's factored, the last step is to take both factors and set them equal to 0. So you remember, you got to finish them all the way till you get final answers. So y'all, the first one, you subtract 4 from both sides. You get s is a -4. And then the second one, you subtract 7. And you get s equals -7. So they'll have the zeros of the function r blank. You'll put in -4, -7. Now let me show you. You can graph this on the calculator. So you could graph this one. So go to y equals, and we'll put in our function. So I'm going to go to the calculator. Only thing is, on the calculator, when you go to y equals, you actually got to use x's instead of s's. So you got to do x squared plus 11x plus 28. Now listen, all I'm looking for is the x-intercepts where it crosses the x-axis at. So if you graph it, you can see you got two places where it's crossing the x-axis. And if you go left, you go -1, -2, -3. There's -4, which was one of our answers. And then -5, -6, -7 was the second place. And y'all, I can verify that by going to those x values on my chart. If I go to -4, my y value is 0. And then if I go up to -7, my y value is 0. So either way on that one, you'll get -4, -7, okay? All right, now number 6 says find the zeros algebraically. So number 6, they got me a f of x equals 5x squared minus the x plus 3. Now, y'all, the difference between 5 and 6, 5 you could factor or graph or do the quadratic formula. On number 6, we have to use the quadratic formula. So 6, that's the only way to do 6 is with the quad because it's not going to factor and you're not going to be able to see the x-intercepts on it, okay? So quadratic formula was x equaled -b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. So we're going to plug everything into this. So let's figure out what a, b, and c are. A is the 5. B, well, there's a negative without a number, so that's a -1. And then C will be the 3. So your numbers will be in order, A, B, and C. So now plug these 3 numbers into your formula. So X will equal negative times my B, which is -1, plus or minus square root -1 squared minus 4 times A, which is 5, and C, which is 3, all over 2 times my A, which is 5. So you get it all plugged in, and now you start simplifying this. 2 negatives will make that a +1, plus or minus, under my square root, -1 squared, -1 times -1 is a +1. And then remember, all this, that this end is getting multiplied. So -4 times 5 is -20, times 3 is a -60. Y'all, all of that is over 2 times 5, which is 10. All right, so we still can work a little bit under that radical. So bring down that 1 plus or minus square root. Well, 1 minus 60 gives me a -59 all over 10. So this is where you would come to the side and try to simplify that square root of -59. Now remember, your perfect squares were 4, 9, 16, 25, 36, 49, and so on. I'm just going to 49 because that's the last one that would be smaller than 59. So 59 won't divide by 4. It don't divide by 9. It don't divide by 16. It won't divide by 25. It won't divide by 36. And it won't divide by 49. So remember, When it don't divide by any of these perfect squares, the number will not reduce. But we cannot keep the negative under the radical. So we bring out that negative as a -1. Now, you can't take the square root of -1, remember, but we replace it. So the square root of -1 becomes I, and then I still got my square root of 59. So on this one, you're going to get a number like me that's negative. You're not going to be able to do nothing to it other than bring out that negative as the I. So this will give me 1 plus or minus I square root of 59 all over 10. And if you remember, MathLab wants this to be written like A plus BI form. Anytime you got I left in your answer, you got to split the fractions apart. So you got to make this a 1 over 10 plus or minus I square root of 59 over 10. You can't leave it as a single fraction in MathLab. You got to break it apart. So this is your A, your real number, and then this would be your B, your imaginary number. So y'all, let's go plug that in real quick. So to do that one, whoops, this was the last one we didn't do. So -4, comma, -7. Now it's probably going to change my number up, but I'm just going to show you how I would put my answer in. So pretend that this was the one I did, 5x squared minus x plus 3. If that was my answer in here, I would do the first fraction bar. I would put in my 1 divided by 10. Arrow right, I would use that plus or minus down here. I would do my fraction again, and then I would do my I square root 59. And then y'all, I would arrow to the bottom and put in my 10. Okay, so you got to split it apart like that in MathLab. All right, number 7, they're giving us everything right here. Okay, so y'all, let me make that bigger. They're giving you the graph, and they just want you to find the x-intercepts and the solutions. Well, the x-intercepts are the 2 black dots, but they got to be written as ordered pairs. So that first one is crossing the x-axis at -3. So that ordered pair would be parentheses -3, comma 0, close parentheses, and then I would do a comma, open parentheses for the second one over here, and that looks like it's crossing the x-axis at 5. So that point would be 5, comma 0, close those parentheses. So the x-intercepts have to have a y value of 0. Now, when it went to the solutions are equal to the x values of those intercepts. So the x values were -3, comma 5. And y'all, all they want y'all to realize on this is that the graph can give you the solutions to these quadratic equations if it crosses over the x-axis. And that's why they want you to realize that these x-intercepts are basically the same as the solutions, okay? Oh, look at this one, y'all. We got the ladder. So let me write down what I got. So the foot of my ladder So the foot of my extension ladder is 9 feet from a wall. Now, the height the ladder reaches on the wall and the length of the ladder are consecutive integers. Then they say, how long is the ladder? So I want to know how long is this ladder? So y'all, this is the one I drew the triangle picture of. So I've got me a wall over here, and I've got my ladder leaned up against it. Now I know that the foot of this ladder is 9 feet from the wall. So this distance right here is 9 feet. Then it tells me the height it reaches on the wall over here and the length of that ladder are consecutive integers. So that's where I came in and said, well, if this height was X, this had to be X plus 1. So that's what they mean by consecutive integers. If this is 5, 5 plus 1 makes this 6. If this is 10, 10 plus 1 makes that 11. We got a right triangle. So this is where we used our Pythagorean theorem. A squared plus B squared equals C squared. C has to be the longest side. And then I'm just going to let this be A and that be B. Y'all's is going to set up exactly like mine other than the 9. Y'all's distance from the wall might not be 9, but you will have an X here and an X plus 1 there. Everything else is going to fit just like mine other than one number on here, okay? All right, so I'm just going to plug in for my variables now. So A squared, A will be 9, so that's going to be 9 squared, plus B, which is X, so that'll be X squared. That's going to equal C squared, which is X plus 1 squared. Y'all will still look exactly like mine other than your number, okay? All right, so let's start simplifying. 9 times 9 is 81 plus X squared. Now here, the X plus 1 squared, I'm going to go to the side. Because remember, X plus 1 squared, we got a FOIL. So X times X is X squared. X times 1 is 1X. 1 times X is 1X. 1 times 1 is 1. And then add your like terms so that this ends up as the X squared plus 2X plus 1. So I'm replacing that right here. So when y'all are working this, at this point, the only difference we can have is this 81. If y'all had a 5 squared, that'd be 25 here. 7 squared, that'd be a 49. But y'all, everything else will look like mine, okay? Now watch this. When I move the X squareds all to one side, well, I can't move the X squareds to one side because when I try to move the X squareds, they cancel here and they're going to cancel here. Y'all's X squareds are going to cancel out just like mine. So that all that's left for me is 81 over here. That's going to equal my 2X plus 1. Y'all, at this point, your only difference will be the 81. Will be whatever number you had here squared, okay? So you're going to solve your final answer just like I'm doing right here. So the first thing, it's not quadratic, so I don't have to factor or anything. I just got to solve it for the X. So we're going to subtract 1. 81 minus 1 is 80, equal to my 2x. And then I want to divide both sides by 2. So notice 80 divided by 2 gives me 40 equal to my x. So 40 is this height right here. But they want to know how long is the ladder. So to get the ladder, I would do my 40 plus 1, and my ladder would be 41 feet, okay? So whatever answer you get here, you add 1 to it and get your ladder. All right, y'all, so for number 8, we would go in and put 41. And move to the next. Hey, also, this is pretty much giving us everything we need also. They're giving me the picture drawn already, okay? And don't worry about this x minus h squared stuff plus k. I'll tell you what, if you're using apps on this and you plug in x minus h squared plus k, it's going to give you the wrong answers on this one. You got to go by this picture, okay? Do not use the x minus h squared stuff at all. So they want the vertex. Well, they're giving me the vertex inside those parentheses right there. That is the vertex. And that is parentheses 3, comma, 1, close parentheses. They're giving me that pair right there. Then it says the axis of symmetry. Well, remember, axis of symmetry is going to be x equals. If you don't put the x equals, it's going to mark you wrong. And the axis of symmetry was always equal to the x value of the vertex. So that means if I drew an imaginary dotted line, drew 3 on the x-axis, and it was vertical, it would cut that parabola right in half. Now they want to know the minimum or maximum value. They don't care if it's a min or max. They just want to know the value. And y'all remember, the min or max value is always equal to the y value. So if you was looking at vertex stuff and you got your ordered pairs, remember the x coordinate does the line of symmetry. The y is the min or max value. Okay? That's what this vertex is telling me, okay? All righty, so I think we filled that in. Yeah, we got the min or max value was 1. Now you don't have to put y equals 1 on that, because that's just a value. The reason we put an x equals is because the line of symmetry is an imaginary dotted line, okay? All right, also, we want to know if this one's true or false. If you got a graph of h of x equals x plus 6 squared, can you be obtained by translating h of x equals x squared left 6 units? So this goes back to the stuff we drew in the parentheses. I said went left or right. Inside parentheses, left or right. If it's being added, we said it would go to the left 6 units. Well, y'all, that's what they said. They said, hey, it'll go left 6 units. So that means this statement would be true. So you're going to look inside your parentheses. If you're plus, you're going left. If you're negative, you're going right. See what they're saying? And then you're either going to agree or disagree with them, okay? All right, now this is another vertex problem. But on this one, they're not giving me a graph. They're just giving me a function. So I'm going to write my function, f of x equals x squared plus 10x plus 16. They want me to get the vertex, max or min value. Range. So remember, the range was my y values. And then the intervals of increasing and decreasing. So remember, the range went off of my y values. The increase and decreasing are going to go off of the x values, okay? So the best thing to do on this one would maybe draw you a little parabola when you figure out what you got. So x squared plus 10x plus 16. A is 1, B is 10, and C is 16. Remember, I need these three numbers when I do my vertex stuff. Now, y'all, the first thing I'm going to do, I don't know where this parabola is going to be, but I know that since that A is positive 1, anytime the A is positive, your parabola is going to look like a U. It might be down here. It might be moved over here. It might be moved over here. But no matter what, if A is positive, you're going to have a minimum. If this A was negative, it would flip it over and you would have a maximum, okay? But as long as it's positive, you got a minimum. So first they want the vertex. So to get the vertex, I'm going to do the formula negative b over 2a, f of negative b over 2a. I find my x value, then I plug it back into my function and get the y value. So to get the x, we're doing negative b over 2a. That's going to equal negative times my 10 over 2 times my 1. So I get negative 10 over 2, which is negative 5. So I know the x value of that vertex will be negative 5. So actually, I need my graph on this side actually, don't I? Now to get the y value, I find f of negative 5. So put a negative 5 in for the x's, you get negative 5 squared plus 10 times negative 5 plus 16. All right, so negative 5 times negative 5 is 25. 10 times negative 5 is a negative 50, and then plus 16. So y'all working through this, 25 negative 50, give me negative 25, plus 16 gives me a negative 9. So actually my graphs would be over here at negative 5, and then down here at negative 9. And it would be shooting up like that somehow. So my vertex was at negative 5, negative 9. So I was just drawing this to show you that it had a minimum for sure. Right here is where it actually is over here at negative 5, negative 9 is my vertex. So the vertex we got right here. They want a min or max value. Well, we know it is a minimum because A was positive. So you got a minimum value, and the minimum value is the y value, which is negative 9. Next, they want the range. Well, my range starts right here, and it's going up. My minimum y value, and as my parabola goes up on both sides, my y values are increasing towards infinity up here. So your range starts with the smallest value. And remember, on the range, you got to use brackets around the number. So the smallest y value right here was that negative 9. And then the y values increase, like we said, as we head towards infinity. And y'all, since infinity don't have a stopping point and it keeps going on and on and on, it always uses the curves, okay? So we got our vertex, we got our min or max and the value, we got a range. So now we're going to do our increasing and decreasing intervals. Now remember, increasing, the graph is going uphill left to right. Decreasing, it's going to go downhill left to right. So this has the left side decreasing and the right side's increasing. So they want increasing first, and these are always in curvy parentheses. The only thing you're putting a bracket on is the range's number, okay? All right, so increasing, the graph starts increasing right here at this x value of -5. So from the x value of -5, as my x values go to the right, my graph is going uphill. As I keep going to the right, my graph is going to keep going uphill as my x's head towards positive infinity. So increasing will be -5 to infinity. So decreasing was this side of the graph going downhill. Now I know where it stops going downhill. It stops going downhill at that x value of -5. So that's where that one stops at. It stops at that -5. Remember, you got to read left to right. So where are these x's coming in from over here? They're coming in from the left. And as my x's get bigger and bigger, it's decreasing till I get to that -5. So we say they're coming in from negative infinity. So that one will start at negative infinity and goes to the -5. I'm decreasing. At -5, I start increasing as I head to infinity. So one of these will start with negative infinity to the number. The other one will go from the number to positive infinity. Now, if your graph's upside down, they'll be opposite of mine.
Will they always be X?
As far as increasing and decreasing, these are always going to be the x values. And then this range right here is always going to be the y values, okay? So that's why on this one, when you're doing these increase and decreases, you can't focus on these y values at all. Okay.
I think
We
that's
can
what I'm
only
struggling
focus
the
on,
most with.
I know. You just gotta somehow train your eye just to focus on that -5 and go, okay? All right, y'all. So let's put that in because woo, that's a lot of stuff to put in on that one. So first we'd have to do the vertex, and it has to be like an ordered pair. So that would be my what? -5, comma, -9. Those parentheses. We said ours opened upward and had a minimum value of -9. But what I like is all these values I'm finding are off of that vertex stuff. Like the range was a bracket and it started at the -9 and went towards infinity and then put a parenthesis around that. And that was the y value still. And then the increasing and decreasing here, my increasing was what, -5 to infinity. And then close those parentheses. And then the decreasing on that when it started at negative infinity and it went to the -5. So these last two, the increase and decreasing, that same number has to be the beginning of one and the ending of the other, okay? But y'all, if you look through here, once I had the vertex, -5, -9, I had the minimum value, I had the range value, and then the -5 gave me the increasing and decreasing values for that one, okay? All righty, so then you remember toward the end of the vertex stuff, they gave us this rocket problem here. So this one is on a launching pad 3 feet above the ground. Initial velocity 48 feet per second. They say the height can be found using the function h of t, where h is the height, t is time. So time is the variable for this one. -16 t squared plus 48 t plus 3. They want to know how long it takes to reach maximum height. So how long does it take to reach maximum height? And then they want to know what is the maximum height. All right, so we'll work this one on pad and then we'll come back and put in our answers on that. Now I'll tell you the formula. -16 t squared is gravity. 48 t is from the velocity. It went 48 feet per second. And then the 3 they got because the starting height was 3 feet above the ground on a pad. So that's how to get in the formula. But y'all, all we want to know is the height and how long it took to get to that height. Well, on the vertex, the time will be the x variable, and the height will be the y value. Okay, so if we can find the x coordinate, that'll give me time. Y coordinate will give me the height. So we're doing the vertex stuff again. So for us, A will be -16. B will be the 48. And C will be the 3. So to get the time, that's like the x. So we're going to do -b over 2a. So that'll equal negative times my b, which is 48, over 2 times my a, which is -16. Now, when you're done with this, it's going to end up positive because we're talking about time, which is positive, okay? So y'all, let's see what I'm getting. I'm getting a -48 over -32. So y'all, let me just punch that on this calculator real quick. So -48 divided by -32 is going to give me 1.5. So it took my rocket 1.5 seconds to reach the maximum height. Now, MathLab will put the seconds. All you got to do is put in the 1.5. So now let's get the height. The height will be h, because that's my function, h of 1.5. So let's plug a 1.5 in for these t's here. So I got -16 times 1.5 squared plus 48 times 1.5 plus 3. All right, so I'm going to plug that in here. So I had -16 times my t, which is 1.5, close parentheses, square that, plus 48 times 1.5, close parentheses, and then plus 3. So y'all, we hit enter, we'll get our height of 39 feet. So in MathLab, you put the 39 and then they'll have the feet out to the side of that, okay? So y'all, that's the trick on that rocket. Just remember. Yeah, I hear you.
I just put I'm just double checking. I just put it in our calculator and did graphed it and was able to come up with a max where it has 1.5 and 39. Is it always like that or is that just a fluke?
Oh, if you're finding the maxes of so when you drew that graph, it should have gave you something like that.
Oh no, it was.
Well, let me go to my calculator. So you went to your TI calculator,
Uh-huh.
all right? And you went to y equals,
Uh-huh.
okay, and you put in so you did negative 16x squared,
Mhm.
plus 48x plus 3, something like that, right?
Yep.
All right, so watch, your graph should look similar to mine.
Yep.
You can't tell it, and I'll tell you why we can't tell it what it looks like. Because this is only going 10 by 10. Well, we
Okay.
got big numbers on this thing.
When I tap it, it comes up and it says max x equals 1.5, y equals 39.
Uh-huh. Um, yeah. And there's also a feature you can do if I hit like second trace here. You see this option number 4 maximum?
Uh-huh.
It'll do that too. So my maximum is in between this side and then let me go to the right some and you see that thing popping down again, that cursor. So I know the max is in between these 2 points when I hit enter. There's your 1.5 and your 39. So hey, as long as you're realizing that you're getting those maxes that way, that's cool, okay?
Okay, I just wanted to make sure it was correct.
Hmm. It's just hard to tell because on mine, if this was 39 feet and then this over here was probably sitting near 100 or so,
Uh-huh.
well, your calculator is stopping at 10 and 10.
Well, and on the actual calculator it is, but on the app, that TI, when you tap on the app, it actually pull like, I mean, you can see it, and as soon as you tap on anywhere on the actual line, it pulls it up and it tells you max, like it just straight up says max y equals 1.5.
Yeah, so and that's one thing that the phone app has an advantage of versus mine. You see, on mine, I had to go through and actually find that max. But that phone app, hey, it's got some things that does a little
I just wanted to
faster.
make sure it was right. That way, if I used it, I wouldn't.
Oh no, you're good. You're good on that. Um, so let's try one. Let's try something then. Let me go to MathLab here. Oh no, it won't let me change my problem probably. Okay, never mind then. Let me put my 1.5 and what y'all say, 39 we said?
Uh-huh.
All right, there you go. And see, that's why I was pushing that with y'all about the x-intercepts and the graph. And if you can't factor, you can at least graph it and figure out where those graphs are, right? Oh, y'all, so one more and then we'll probably do a break here. So find the domain f of x equals a square root 5x plus 3. Now, I will say this, on this radical stuff, we took what was underneath, the 5x plus 3, and we set it greater than or equal to 0. I would solve this, subtract 3 first. So I get 5x is greater than or equal to negative 3. And then y'all divide by 5. So that my x is going to be greater than or equal to my negative 3/5. Now, every one of these I've seen, um, these 5x's, 4x's, whatever, if your x is positive, your little inequality is going to end up just like mine. So focus on this, greater than or equals. And look at these answers. The only thing they're changing is the greater than or equals, not equals, less than or equals. Well, B, we only use the not equals if it's a fraction, remember. Fractions, we said, were not equal to. Inequalities either have to be greater than or equal or less than equal. Well, we didn't divide by negative and flip ours. So ours is going to stay greater than or equal to that negative 3/5. So y'all on this one, your only answers for this one could be an answer like A and C. And I'm going to tell you, 95 of y'all are going to have the inequality looking just like my A did. Unless your X is negative, you're not flipping it, okay? So the inequality has to point in the same direction as mine did for A. Other than that, all the answers are the same. Negative 3/5 for all of those, okay? If you put D, you will miss it 100%. If you put an answer like B, you're going to miss it 100%. It's either going to be a number like A or C. Oh, hold on, y'all. We said we're doing break, so I'm going to stop my share for a second and pause our recording and then go back to Math Lab. All right, y'all. So on the next couple, we just have to graph these. So y'all, I'm just going to go to my calculator, let it graph this. But I will say, remember that x minus 5 is like it's in parentheses. So it would move our graph right. So we would find one that looks like it moved right. And that'd be D really. But y'all, let's go graph it and make sure. So I'm going to go to y equals and clear everything out. Oh, and hang on, let me find out what that square root of x minus 5. So second x squared to get the radical, and then x minus 5. All right, y'all, so I just want to see the graph to see what it looks like. And notice when I hit graph, it moved it right 5 units. So y'all, we would just go back to Math Lab and pick the one that went right 5, and that would be D. Okay. All right, so we got that. We go to next. And it's going to be another one just like that. Except this one, they got a 5x minus 4. So let's go graph that one and see what happens. So y equals, clear that out. So second x squared, and that was what, 5x minus 4. All right, but y'all, all we want is the graph again. So let's hit graph. And notice it moved it right. Just a little bit, but it did move it right. So let's look at the graphs. So A looks like it went right. B flipped around somehow. C went left a little bit, and then D is a straight line. So the one we need that went right and looks like our graph would be A. All right, y'all, we picked that. Move on to the next one. So y'all, this one, they only want to know which of these 3 equations I would use if I wanted to find f of -1. So you got to figure out, is -1 less than -1? I would use the x minus 4. The second one says -1 can be less than or equal to your x, which is -1, less than 4. We all? -1 less than or equal to -1. That's the one I need because I'm using -1. So I would use the x squared equation. So I would choose A for that one. Okay, so you got to be careful. The top one, the x less than -1, it don't have equals on it. So that would be any number like -2, -3, -4. Anything less than -1. Well, the second one says -1 less than or equal to your x, which is -1, and still less than 4. So that would be like 0, 1, 2, 3. Anything that equaled 4 or greater than 4 would use that 3x equation, okay? So you go by the domain on that one to see which equation you would use. So y'all, let's make this one a little bigger here. Now look, they're giving me the vertex. The vertex says 3.5 and then 3.25. That is the vertex. Okay? So it says over here, does it have a relative max or minimum? Well, that's a maximum because it's a mountaintop. So that's a maximum. So we would click maximum. It occurs at what x value? Well, the x value was 3.5. They gave me the actual point, 3.5, and the maximum value would be the 3.25. So the x equals gets the x value, and then the value is the y value. Then it says, where is it increasing? Well, that's the left side of it. Although that arrow's pointing down, that's not the direction it comes in. That just means the graph goes on forever. So this left side is going uphill. And we're concerned with those x values. So it comes in from negative infinity as you're cruising down to x's until you get to that x value of 3.5. So y'all, the increasing would be negative infinity to 3.5, which means the decreasing starts at that 3.5 on the x-axis and heads to positive infinity. So that one would be from 3.5 to infinity. So if yours is upside down like mine, you're going to start at negative infinity to the number and then go from the number to infinity for the decreasing, okay? All right, y'all. So that's all we had to do to that one was just look at it and get the maximum and then the intervals. All right, y'all. So 18, we actually got to do some work on this one. So let me write down what they're giving me. H of x equals negative 2x minus 12 for any x's less than negative 8. It equals 3 for negative 8 less than or equal to your x less than 3. And then it equals x plus 6 for any x's that are greater than or equal to 3. So they want h of negative 9. They want h of a negative 6, h of 3, and then h of 6. So I'm going to work these out, and then we'll come back and put them into our answer blanks. Okay, so starting with negative 9. Is negative 9 less than negative 8? Well, that's true. Numbers that are less than negative 8 will be negative 9, negative 10, negative 11, negative 12. All these kind of numbers, negative 13, all the way to negative infinity, all these numbers are less than negative 8. So negative 9 is less than negative 8. I use the first equation. So that'll be negative 2 times x, which is negative 9, minus 12. So all right, negative times negative makes that a positive 18 minus 12, which is 6. Now at this point, you can punch this on the calculator. So then they got h of negative 6. Well, negative 6 is not less than negative 8, so I got to look at this equation. So if this was my negative 6, well, negative 8 would be less than negative 6, and negative 6 would still be less than 3. So negative 6 is in between this range. And this range will cover numbers from negative 8 all the way up to 2. because 2 is less than 3 is the biggest number that can be in that range. Well, y'all, -6 is right there, so it's in that range. So I use the second equation, and there's no variable here, so anything in this range equals 3. All right, h of 3. Well, it can't be this equation, this domain here, because we don't have 3 listed, because 3 is not less than 3. So I go to this equation. X can be greater than or equal to 3. So to be in this range, X can be 3, 4, 5, 6, 7, 8, 9, 10, da 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 da. Anything towards infinity. Anything equal to 3 or greater than goes in this category. Well, 3 is equal to 3, so we put a 3 in for the X. I get 3 plus 6, which equals 9. And then finally, h of 6. Well, 6 is greater than 3. And remember, it's in this range of numbers we said. So I would use this equation again. So I would put a 6 in for the X. And then 6 plus 6 gives me 12. So every time I've done this problem, I had one there, and then the last two always did that last equation, okay? None of y'all, so that's the trick on 18 was just keeping squared away with those. So I had a 6, 3, 9, and a 12. So you put in all 4 of those numbers and hit next. Oh, so the difference quotient, f of x plus h minus f of x all over h. And y'all, the first one they're giving me, f of x equals 3x plus 6. All right, so this one wasn't bad. This one's the one where I got a single number, because remember, this is a straight line if you was to graph this. But we're not worried about that, y'all. We're going to knock it out with this formula right here. So the first thing I got to find, f of x plus h. That equals this function, and I'm going to put an x plus h in for that x. So I get 3 times x plus h plus 6. And then the only thing you can do to that is get rid of the parentheses by distributing that 3. So 3 times x is 3x plus 3 times h is 3h. And I still got my plus 6. So this is all now f of x plus h. So we're going to plug it into the formula. The f of x plus h minus the f of x will all be over that h. So plug it in. This will be the 3x plus 3h plus 6. This will be the f of x, which was 3x plus 6. And y'all remember, when you drop parentheses, you got 3x plus 3h plus 6 minus 3x minus 6 all over that h. But this is where stuff cancels. If it don't have an h, it's going to cancel. So the 3x cancels with a negative 3x. The 6 cancels with negative 6. So you're left with a 3h over h. Well, y'all look at that. Those h's cancel. And my final answer is 3. Okay, so 19, not bad. You ended up with a single number for the slope of that line. And that's basically what this is finding is the slope, okay? So let's look at the last one. And the last one's going to be a little trickier. So y'all, we got to put this one in first. So for 19, we got a 3. And then we're on number 20. So our last test question is the same thing. But y'all look at my f of x, it's a little more complicated. I got a negative 4x squared plus 7x plus 7. And we're still using our difference quotient. F of x plus h minus f of x all over h. So we'll go work this one. And y'all, I will say this. This one will have more than just one number for the answer. Because it's got an x squared. It's going to be the parabola stuff. So you're going to get more of an answer than we did on number 19, okay? But y'all, the first thing again, we got to find f of x plus h. So we need to put an x plus h here and an x plus h there. So 2x is getting replaced. So this will equal negative 4 times x plus h squared plus 7 times x plus h plus R7. All right, y'all. So the first thing we got to do is FOIL the x plus h squared out. So I'm going to bring down to negative 4. Now, if you remember, I'm not going to FOIL it all the way out, but we know what x plus h squared is. This is what I told y'all to save for all these problems. But that equaled x squared plus 2hx plus h squared. Remember, we got that by doing x plus h times x plus h. But anytime you get an x plus h squared, replace it with this. So x squared plus 2hx plus h squared. And y'all, I'm bringing everything else down. 7 times the x plus h plus my 7. So look, this was a little more work than the one on 19, okay? All right, next, the only thing you can do is get rid of parentheses. So multiply negative 4 times these 3, multiply 7 by them 2, and then bring down that 7. So I get negative 4x squared. Negative 4 times 2 is a negative 8hx. Negative 4 times h squared is a negative 4h squared. So that's the first 3. Now I'm going to do 7 times x is a 7x. 7 times h is a 7h. And y'all, at the end is your plus 7. All of this is the f of x plus h. And nothing cancels yet, and nothing combines for like terms. So then I'm going to plug everything into the formula. And all of that is over my h. So f of x plus h is this. Negative 4x squared minus 8hx minus 4h squared plus 7x plus 7h plus 7. F of x was negative 4x squared plus 7x plus 7. Now, I'll show you what I do on these ones. Since it's longer, and I know everything that does not have a h is going to cancel. So this negative 4x squared here cancels with that negative 4x squared because that's really a positive 4x squared. Negative and negative make that a positive 4x squared. This negative times this 7 makes that a negative 7x, negative 7x. cancels with a 7x. And then remember, this is like a -7. Well, that -7 is going to cancel with that +7. So find these three over here and cancel them. All that's left is the -8hx minus 4h squared plus 7h all over your h. And y'all, I'll draw this out real quick and show you what's got to happen. But everybody on top has to get divided by the h on the bottom. So these h's cancel, you're left with a -8x. Remember, h squared is h times h, so one h cancels with that h, leaving a -4h. And then here, the h's cancel, leaving me a +7. Once you've simplified the h's, there's no other like terms, nothing else you can do. Final answer. Okay, so then I think we had to actually put that one in, right? So let's go look. Yeah, I had to come in and do -8x minus 4h plus 7. Okay, so you got to come in, put in that answer on that. Y'all, number 20 is the last one, so then we could submit our quiz. And submit. Oh, we missed one. Let me go to number 6. See what this was. Oh, no, that's the one where I did it with a different number, remember? I did 5x squared minus x plus something else. So we knew we'd miss number 6 because I used my own answers. Okay, we remember we got 59 instead of a 15. So we did it right for the number I used. So that's why we missed it on here. Okay. All righty, y'all. So I'm not getting into the next test material yet. We'll wait till tomorrow to start on test 3 material. So tomorrow we'll knock out like 8-1 and 8-2. Thursday we'll do 8-3 and 8-4, and then so on, okay? So I didn't want to get into the next material. I wanted y'all to focus on test 2 today, okay? All righty, y'all. So let me stop that recording.